The universe keeps secrets. Most of them we can unlock with light. We use telescopes to read the history of the stars. But there is one secret that locks itself away. In 1783, a geologist named John Michel asked a terrifying question. He knew that gravity pulls things back down. If you throw a stone, it falls. If you shoot a cannonball, it falls. But if you shoot it fast enough at near escape velocity, it leaves the Earth forever. Michel calculated that if a star were massive enough, the escape velocity would exceed the speed of light. Nothing could leave it, not even a reflection. It would be a dark star, a hole in the sky. For centuries, this was just a ghost story for mathematicians. But in 2019, we pointed our radio dishes at the heart of galaxy M87, and the ghost appeared. How does nature break space-time? It begins with the death of a king. A massive star is a constant battlefield. In the core, nuclear fusion pushes out. Gravity pushes in. For millions of years, they are locked in a stalemate. But eventually the fuel runs out, the fire dies, and gravity, which has been waiting patiently for eons, wins the war instantly. The core collapses. It crashes inward with so much force that it crushes atoms. It crushes neutrons. It squeezes the mass of 1,000,000 Earths into a space smaller than a city. It punctures the fabric of reality. What is left behind is not an object. It is a location. And it is guarded by a boundary called the event horizon. This is not a solid surface. You could fly through it and feel nothing. It is a shadow line, a point of no return. Imagine a river flowing towards a waterfall. As you get closer to the edge, the water moves faster. The event horizon is the point where space itself is flowing inward faster than light can swim upstream. Once you cross this line, there is no out. There is only in. All paths, all futures, and all timelines lead to the center. As we approach, the monster physics begins to warp. Before we hit the event horizon, we cross the photon sphere. Here, gravity is so intense that light itself is trapped in an orbit. Photons are circling the black hole like satellites. If you could hover in this spot and look to your side, you would see the back of your own head. You are standing in a place where the past is circling in front of your eyes. The light from millions of years ago is trapped here, creating a ghost image of the universe's history. Now imagine you jump. You fall toward the blackness, but to your friend watching safely from the spaceship, something strange happens. As you get closer to the horizon, your friend sees you slow down. Your image turns red. Your movements become sluggish. Eventually, right at the edge, you stop. To the outside world, you never fall in. You become a frozen star, pasted onto the surface of the black hole, forever fading slowly into the dark. Relativity dictates that time stops at the edge. To the universe, you are immortalized in the moment of your death. But from your perspective, everything is different. You don't stop. You fall right through the horizon, and then you feel the tides. Gravity gets stronger the closer you are to the center. The pull on your feet is billions of times stronger than the pull on your head. You are stretched, elongated. Science calls this spaghettification. It is a silly name for a violent end. Your bones snap. Your muscles tear. Finally, your atoms are ripped apart into a single vertical line of subatomic particles. You enter the dark not as a human, but as a stream of data. Where does the stream go? It falls to the center, to the singularity. This is the place where science goes to die. According to general relativity, all the mass of the star has collapsed into a point of zero volume and saw infinite density. Imagine the Earth crushed to the size of a marble, then a grain of sand, then an atom, then nothing. But the mass is still there. It is a scar on the face of reality. It is a place where space and time no longer exist. The singularity is a problem. It is the battleground for a civil war in physics. We have two rule books for the universe. General relativity governs the big stuff star's gravity time. It says space is smooth like a sheet. Quantum mechanics governs the small stuff atoms' particles. It says space is pixelated and chaotic. Usually, they stay out of each other's way. But in a black hole, the big is crushed into the small. Both rule books try to apply at the same time, and they scream at each other. The math breaks. We get answers like infinity, which in physics means we are wrong. But the biggest casualty of this war is how information. Quantum mechanics has a golden rule. Information is never lost. If you know the state of every particle in the universe today, you can theoretically calculate the past. The movie of reality can be rewound. But if you throw a book into a black hole, it crosses the horizon. It is gone. According to relativity, it is cut off from the universe. The data is erased. The movie cannot be rewound. This is the what's information paradox. In 1974, Stephen Hawking found a clue. He realized that black holes are not truly black. In the vacuum of space, virtual particles are constantly popping into existence in pairs, matter and antimatter. They usually collide and vanish instantly, but at the event horizon, sometimes one falls in and the other escapes. The escaping particle becomes radiation. It looks like the black hole is glowing. We call this Hawking radiation. This glow comes at a cost. To fuel this radiation, the black hole loses energy. It loses mass. It is slowly bleeding to death. Over unthinkably long timescales, googles of years, the black hole will shrink. Eventually, it will get small, unstable, and explode. It will vanish from the universe completely. And this is where the paradox becomes a crisis. If you burn a book on Earth, the information is not destroyed, it is scrambled. If you collected every molecule of ash and smoke, you could technically reconstruct the text. The data is still there. But if a black hole evaporates, it leaves behind nothing but random radiation. The book is gone. The star is gone. The astronaut is gone. If Hawking is right, black holes are deleting the universe's hard drive. And physics says that is impossible. How do we save physics? How do we stop the library from burning? The answer came from physicists Jacob Bekenstein and Stephen Hawking. They discovered something strange about the math of black holes. Usually the amount of stuff you can fit in a container depends on its volume, the space inside. But for a black hole, the amount of information it can hold depends on its surface area, the skin on the outside. This suggests that the book doesn't fall into the center. The information of the book gets plastered onto the event horizon. The physical pages might be crushed, but the data is stored on the shell. Think of a can of soup. The soup is 3D. It has depth, it has taste. But everything you need to know about the soup, the ingredients, the calories, the brand is written on the label. The label is 2D. A black hole works the same way. The soup, the star the astronaut falls in. But the label, the data describing them stays stuck to the event horizon. The information isn't lost. It is just reformatted. This leads to the Holographic Principle. It suggests that the 3D reality inside the black hole is actually a projection of the 2D data on the surface. The astronaut inside feels like they are falling. They feel 3D. But from the universe's perspective, they are just a scrambled code on a flat screen. It is like a video game. The game world looks 3D. You can walk around in it. But ultimately, it is just 2D code written on a hard drive. The black hole is the hard drive. The interior is the simulation. But if this is true for black holes, it might be true for YGs. Physics suggests that the maximum amount of entropy in any space is defined by its boundary. We might be living inside a black hole right now. Not a literal one, but a mathematical one. Our entire universe, the stars, the galaxies, your house, you might be a 3D hologram projected from the edge of the cosmos. We feel solid, We feel real, but we might just be shadows on the wall. There is one final theory. If black holes are the drain, where's the faucet? General relativity allows for the existence of white holes, regions of space that cannot be entered, only left. They constantly spit matter and energy out. We have never seen one, unless we are living in one. The Big Bang was a moment where matter and energy suddenly exploded out of a single point. Perhaps our universe is just the exhaust pipe of a black hole in another dimension. This leads to a theory called cosmological natural selection. Physicist Lee Smolin suggests that black holes are not dead ends. They are seeds. Every time a black hole forms, a baby universe might be born on the other side of the singularity. This new universe might inherit the physical laws of its parent. If this is true, our universe was not an accident. It was born inside the black hole of a previous universe. We are the children of a dead star in a reality we will never know. We used to think of black holes as monsters, as cancer, but perhaps we should see them as anchors. Every massive galaxy we see has a supermassive black hole in its center. Sagittarius A sits in the middle of our own Milky Way. It is the eye of the storm. Without these gravitational titans, galaxies might not form. Stars might not cluster. Life might not have a safe harbor to evolve. They are not the destroyers of worlds. They are the architects. We have traveled to the edge of time. We have looked at the boundary of reality, and we have found a mirror. The black hole represents the ultimate limit of human knowledge. It is the place where our math fails, where our logic breaks, and where our intuition dissolves. But it is also a promise. It reminds us that the universe still has secrets, that there are still dragons on the map. And as long as there is darkness, there is something left to explore.